Hi all, this will be the fourth part of civil engineering basic knowledge. Today we'll be discussing on the basics about the another structural element called as a slab. Okay, already it is a slab. That means whenever you go for a foundation or footing, this is the footing part is same as that of your slab. Okay, as the parameters which we consider for a slab will be considered here. Okay, mainly the thing is that whenever you fix the size of footing, all you required is SBC, that is safe bearing capacity of a soil is required. SBC of soil is required to design the footing. Okay, it is mainly done based on the test conducted, that is the shear test. Before that I'll go for the sampling. Sampling means collection of soil sample, and later we'll conduct the shear test, and from the shear test I'll be getting a value of C and phi. Using the C and phi I can get the value of SBC. Whenever you get the value of SBC, easily can design the footing based on the capacity of the subsoil. Okay, so for example, the capacity of subsoil is 200 kilonewton per meter square, and load acting on footing is 800 kilonewton, the factor load, and the area of the footing will be calculated as, this is load, this is stress, or you can write it as gamma. Okay, stress is equal to load by area, and area is equal to load by stress. Okay, now here load is 800 kilonewton and stress is 200 kilonewton per meter square. So when you calculate, it will be area of the footing is required is equal to 4 kilonewton per, sorry, this is 4 kilonewton cancel each other, so total area is 4 meter square. In this way we'll be finding the footing. Later I'll let you know how to design in the any other video. So here we are only discussing on the basic parts. Okay, and whenever you calculate, you will be getting a moment in a footing, and the minimum percentage of reinforcement for footing is equal to 0.12% of the total cross sectional area, that is B into D, the total cross sectional area for HYSD bars. If we are using MS bars, it will be taken as 0.15% as per the IS guidelines given for the footing. Okay, and earlier in the last video we have discussed about the design of or the basics about the column, whereas the minimum percentage of reinforcement for column is around 0.8% of B into D, and the maximum percentage is around 6% from B into D. Okay, this guideline is given in IS 456 page number 48. When you refer this code, you will be getting the things very well. Whenever you design, okay, if you want to become the master in any of the structural subjects, okay, you must refer the first code, that is the basic code IS 456. Okay, and when it comes to the footing part, okay, this is a plate element. Whenever the force is applied, for example a column is there, a moment will be there, that is upward intensity of pressure will be there, that will leads to a moment, and apart from that a punching shear will act here. The periphery of the column, the punching shear will act. First one, the axial load need to be considered, any moments on the footing need to be considered, and the punching shear will be considered. And apart from this punching shear also, one way shear is there. Okay, shear on one side, that means the normal shear need to be considered for design of the footing. And based on these things, that is moment, punching shear and shear, okay, we'll be designing the depth. And you know how to calculate L and B. It is mainly depends on L and B depends on the SBC and the axial load acting, and whatever the moment is there, moments will cause the pressure at the bottom of the footing, that is P max and P minimum. Okay, I'll show you the figure. Okay, so suppose if this is a column, this is the column and this is the footing. Okay, whenever the force is acting, it will be evenly distributed and the upward intensity of pressure will be distributed evenly. Whenever there is a moment, okay, if there is a couple or moment is acting on the footing, okay, that will leads to a maximum and minimum stresses. That is, here we will be getting the maximum stresses. This is P max and P minimum. Okay, these need to be considered whenever there is a moment on the footing. That means the P minimum should not be less than whatever the P minimum is there. It should not be less than 0. That means it should be greater than 0, and P maximum should be less than SBC of soil. Okay, you need to maintain, whenever you design the footing, you need to maintain these two main properties. Okay, and apart from this, as I said, the guidelines, okay, minimum percentage of reinforcement is 0.12% for HYST when you are using HYST bar. These things to be kept in a mind whenever you design or you study about the basic elements. Okay, so since from the 4 videos we are discussing or we are studying about basics of slab, beam, column and footing. Okay, these are all are the structural elements of a building. So we have discussed the basics on these things. Okay, so in the next video we will be discuss some more on the materials, that is the reinforcement, concrete, many materials are there which code to be referred, and apart from that we will discuss the codal provision also. Whenever you design a building, all you required is IS 875 part 1 for dead load and dead load considerations, IS 875 part 2 is for the live load considerations, imposed load, and IS 875 part 3 is for wind load considerations, IS 1383 is for the seismic load considerations or earthquake load considerations. And next, the main thing apart from this, all you required is IS 456 for the limit state design, of these elements, all the elements. Okay, so this is all about the basics of civil engineering. The basic parts need to be discussed. Okay, so here in the next video, that is in the part 5, so this will be the part 4 of basics of civil engineering. So in the next video we will discuss more about the basics of the civil engineering. Until then, thank you. If you not yet subscribe my channel yet, please subscribe and press bell icon for upcoming videos. Thank you.